We are recording. Okay, so Sanjay asks, when we are using the definition of the derivative, will it always tell us what a equals? Yes, they do need to give you a if they're going to ask you to find that specific value. If not, I'm trying to think, can we? I mean, technically we could do it in general, but no, usually they'll give you the a value. Or will it be something like 9 through 12? 9 through 12. Yeah, see, okay, so 9 through 12, you're finding the derivative in general, right? So you'll still have x's. But if they give you the value of a, then you could still do it like 9 through 12 and then plug a in at the end, but it's easier to just plug in a right from the beginning. So most of the time they'll give you that a value that you're wanting. They're wanting you to find the derivative right at that value. So you're finding the slope at that value. So when you're talking about a curve, right, the slope changes as the curve, depending on where you are on the curve. So they usually will ask you what the slope is at a specific x value, which is that a value they're giving you. But we could say just, find f prime of a, and that's going to give you in general. And then what you can do is, then what that does is it gives you the derivative just in general, and then you can always plug in all kinds of values into the x or into the a. And so that's the difference. So you could see both. Most of the time we actually give you the actual a value though. Number 15 on the quiz, brief review. Okay, so quiz 15 is, they gave you this graph that went like this, and that. Something like that, right? And right here it was when x is 1, and right here was when x is 2, and then my graph is really funky, but that's when x is 3. Okay, so it says on this interval from 0 to 1, right? So you're talking about x values. This is an interval notation from when x is, so this is like from when x is from 0 to 1. That's what we're looking at. What we see is, and by the way, this was the velocity graph. This is the graph to the right, shows the velocity of the particle. So you want to make sure you're paying attention to, is the graph that they gave you, is it the position graph or is it the velocity graph? Later on, we'll give you acceleration graphs also. I don't think we saw that yet, but we could, right? And so anyway, okay, so from 0 to 1, you're this graph here. Well, the velocity, your velocity is definitely negative. You're talking about, this is the velocity graph, so your y values are below the x-axis from 0 to 1. So since the graph is below the x-axis, and then your acceleration is the slope of the velocity. Well, this is also negative since the slope is negative. It's also, yeah, as you're going right, you're going down, right? So in general, so the velocity is negative means that it's moving backwards. Moving backwards, and that comes from velocity. If velocity is positive, then it's moving forward. If velocity is negative, then it's moving backwards. And then because they have the same sign, velocity and acceleration have the same sign, then it's speeding up. If they have opposite signs, then it's slowing down. So I guess I should have started with that, with the generalization. But moving forward or backward depends on your velocity, if it's positive or negative. And then whether it's speeding up or slowing down, then it's if they have the same signs. All right, and then the next interval was from 1 to 2, and so now you're talking about this part here, which your graph is, the velocity is negative because it's below the x-axis, and your acceleration is the slope of this section, and the slope is a horizontal line, so the slope is 0. Your acceleration is 0, and so that means you're still moving backwards, and that's because your velocity is negative. Velocity, positive versus negative, tells you forward or backwards, but then because your acceleration is 0, you're at a constant speed. Your speed is constant. You're not speeding up or slowing down. You're staying constant. All right, then from 2 to 3, we're talking about this section here. Okay, so from 2 to 3, you've got let's see, I really don't want to have to, nope. Can I select it? Oh, what'd you do now? Okay. Can I select this whole thing? Trash it? Almost. Well, it didn't work as nice as I thought it was going to, but okay. So now from 2 to 3. On the interval from 2 to 3, then you're this gray line. I've got your velocity is still negative because your graph is below the x-axis, and then your acceleration, though, is positive now because you've got a positive slope. As you're going from left to right, your graph is increasing. You've got a positive slope, and so acceleration is positive, which means that you're moving backwards still. Moving backwards because velocity is negative, but now velocity and acceleration have opposite signs, and so you're slowing down. All right, and then on the interval from 3 to 4, all right, now your graph is above the x-axis, your y values are positive, so velocity is positive. Acceleration, what's the slope of that line from 3 to 4? Right, is also positive. It has a positive slope, and so now you're moving forward because velocity is positive, and you're speeding up because they have the same sign. Velocity and acceleration have the same sign, so they're speeding up. On a side note, we did not ask this for 15, but maybe you will need to know. Your particle is stopped when velocity equals 0. And so it's going to be at t equals 0, and then again at t equals 3. You've got your particle is actually stopped at those points. So, all right, hopefully that helped. With that, is the rate of change, instantaneous velocity, and derivative all basically the same thing? Kind of, except for one thing. So average velocity. Average velocity is the slope you've known since 6th grade. It's the y minus y over x minus x. So what they'll do is they'll give you two values. Like they'll say find the average velocity between when time is 2 and time is 4, right? And they will have given you some function like f of t equals, I don't know, t squared minus 2t plus 3. I'm making crap up, I don't know. And so what you'll do is you'll actually go, okay, this is f of 4 minus f at 2, and then all over 4 minus 2. So that's average velocity. Average velocity is that. Now, instantaneous velocity is the derivative. Instantaneous velocity, okay, is the derivative and it is the slope of the curve, right? So if you've got like, I don't know, let's say you got a curve and here's T2 and here's T4. Okay, so, or time when time is 2 and when time is 4, this is what the slope of the average velocity will give you, versus we can say what's the instantaneous velocity. We're not going to give you between two times. We would say what's the instantaneous velocity. Let's say at t equals 2, it's going to be this slope here, which is the tangent line. It's the slope of the tangent line, which is the derivative of the curve, and that is slope. So yes, kind of the same thing, except for average velocity is not the same thing. 15 on the multiple choice. Hopefully it's not a crazy one. Okay. Did not grab my calculator, hopefully. Okay, so this is the multiple choice, number 15. I always forget something. Okay, so at time t, the position of a moving particle along the s-axis, all right, is s is t cubed minus 27t squared plus 240t. That's the position. They want you to find the acceleration each time the velocity is 0. So velocity will be the derivative of this guy. So 3t squared minus 54t plus 240. All right, and then we want the acceleration each time the velocity is 0. So the first thing you want to do is find when this velocity is 0. All right, does 3 go into everything? I hope so. 3 would be 118, I think, and then 80. Oh, yay. Nice. Okay, so then that'll give you t minus 10 and t minus 8, I believe. Tell me if I'm wrong. That should be it. Okay. And so that means the times your velocity equals 0 at t equals 10 and when t is 8. So at 8 seconds and 10 seconds, your velocity is 0. And your particle is going to be stopping there. So they want you to know, they want to know what's the acceleration at each of these times. So acceleration is going to be the derivative of velocity. So take the pop and drop, 6t minus 54 is going to be the derivative of velocity. And so your acceleration at 8 seconds will be 6 times 8 minus 54, which is what, 48 minus 54. I think that's a -6. Is this the exact same question from the quiz? I hope not. I hope it's different numbers. Oh no, it was different numbers. It's just very similar, huh? Unless I'm making an error. And then when it's 10, we've got 6 times 10 minus 54, which was a +6. And so your answer was C. So those were the acceleration values, and obviously it's meters per second squared and meters per second squared. You wanted the acceleration values at each of those times when your velocity was 0. All right, that's that one. The logic of number 14 on the quiz is that they gave us the displacement. I don't think that's number 14, Sanjay. On the quiz, 14 on the quiz was the area of the circular oil spill. Which one was displacement? They gave us the displacement. they gave you the area of a circular oil spill, and then when they're asking you for rate, rate is derivative, yes. So rate is rate of change, which is derivative. And so what's the rate of change of the area, which is the dA over dr. I don't know, displacement isn't the right word for it, I don't think, but yes, to rate of change, derivative, yes. Number 11 on multiple choice. All right, so they gave us y equals x cubed minus 3 over 9x, where x equals 1, and they want the equation of the tangent line of that at that point, of the curve at that point. Okay, so for an equation of a tangent line, you need a slope and a point. Well, you can find the point right away. The point would just be when you plug a 1 into y. I'm sorry, 1 into x, so 1 cubed minus 3 all over 9 times 1, which is what, negative 2 over 9. So your point is 1 comma negative 2 over 9. Hopefully tell me if I did something wrong. And then your slope is going to be the derivative. And so you could do this one or two ways. You could do quotient rule. Maybe we should practice quotient rule. The other thing is, because there's only a single term in the bottom, you could reduce this. You could rewrite it. I'm just going to use quotient rule though, because even though you could rewrite it, if there's a binomial in the denominator, you can't rewrite it and simplify it. So I'll just do quotient rule so that way I don't confuse you. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. And we want this, so yes, I can simplify and all of that, but the slope, we want it when x is 1, and so I'm going to plug a 1 into x, make my life easier. So it would be 9 times 1 times 3 times 1 minus a 1 minus 3 times 9 all over 9 times 1 squared. And so what's that? 27 minus negative 2 to negative 18. Was it 3x squared? Isn't the original 9x? No. Oh. Yes, thank you. 9x times 3x squared. Good catch. Thanks, Bailey. It still didn't affect when I plug in a 1, thank goodness, but you're absolutely right. It should have been a 3x squared. And then over, and then, okay, good. And then all over 81. And so what is that? 45 over 81 is going to be your slope. And so it's a y minus negative 2/9 equals 45 over 81 times x minus 1. You can leave this if it's in the free response part. This is multiple choice though, so we have to just simplify. And if I was smart, I would have simplified this and made it 9 goes into both, right? So 5 over 9, that would make my life easier. How about a 5 over 9? If you, what do we want? They put it into that form. Okay, so we've got y plus 2 over 9 equals a 5 over 9x minus 5 over 9. And then you want to subtract 2 over 9, so y equals 5 over 9x. 5 over 9, negative 5. Okay, so minus 7 over 9 is what I got. B. Yep. All right. Okay. On a side note, I'll show you really quick how you could also separate it x cubed minus 3 over 9x is equivalent to, separate it, but when you separate it, you got to separate this and that, right? So it's a 1 over 9 x squared, or how about if I write it as x squared over 9, just so that way. One more, go. X squared over 9, and then minus 1 over 3x, like that, which is equivalent to 1 over 9 is your coefficient on x squared, and minus 1/3 x to the negative 1. And so when you do the pop and drop, it would be 2 over 9 times x to the power of 1 now, plus 1/3 x to the negative 2. And then when you plug in a 1, so now y prime at 1 would be 2 over 9 plus 1 over 3, because when you plug in the 1, and that's a 3 and a 3, and that gives you 5 over 9. Is that what I said it was? Your slope was 5/9, I think. Let me go back one page. Was the slope 5/9? Yay, 5/9. Okay, so that's your other way. But you can only do that because it's a monomial, right? There's only a single term in the bottom, and you could split it up and do pop and drop that way. So there is that way also, but as soon as there's a binomial in there, you can't do it, and so that's why I went ahead and did quotient rule. We make sure that you have to know quotient rule, so good to practice. Okay, so that was 11. Number 32 on page 146. Okay. And 31 and 32. So this is page 146, number 32. So they give you this picture, and they give you the equation is y equals 1 plus rad 2 cosecant x plus cotangent x. And they give you point P is this pi over 4 comma 4. And then Q, we want tangent to the curve and the horizontal tangent. Q, they don't give you a point, but what you know, well, we don't know what Q is. We'll get that in just a minute. But we know it's a horizontal line so that the slope is 0. So, yeah, anyway. Okay, so let's start with, we're going to find the tangent to the curve at P. And so, tangent, find the equation for the tangent. All right, so we got a point already. We need the slope. And the slope will be y prime, which is derivative of 1 is 0. And then plus, okay, so here's your little trick. Remember, so if you Googled this, you might have found the trick of pst, pst. So SST, pst, which is secant, secant, tangent, which means if you take the derivative of secant, it's secant times tangent. If you take the derivative of tangent, you go this way, and it's secant squared. And then, so you've got pst, and then you go cosecant, cosecant, cotangent, like that. You take the cos of each of these guys with a negative in the middle of the cos, and that means when you take the derivative of cosecant, it's negative cosecant times cotangent, and when you take the derivative of cotangent, it's negative cosecant squared. Okay, so what does that mean for us? When I take the derivative of rad 2 cosecant of x, we still have the rad 2 because that's just a constant times the thing, and then derivative of cosecant is a negative, so I should throw the negative out front here. Well, I'll do this. It's negative 2 times, or rad 2 times negative cosecant of x times cotangent of x. And then derivative of cotangent is a negative cosecant squared, oops, of x. Yeah. And then at pi over 4 is what we want to know, because that's your x value for your point there. This would be rad 2 times negative cosecant is reciprocal of sine. Okay, so pi over 4. Pi over 4 is the 45-degree one, right? And that is a cosine is rad 2 over 2. Sine is rad 2 over 2. And so cosecant would be 2 over rad 2. So it ends up being a rad 2. Times cotangent is x over y, which would be a 1. All right, then we got minus cosecant squared, and cosecant squared is reciprocal of sine, so rad 2 quantity squared. And so this ends up giving you, what is that, a negative 2 minus 2, so it should be a negative 4. Yep, okay. And then let me remove this. Trash it. Bye-bye. Yay, that worked. Okay, so we got a slope of negative 4, and your point is, oops, pi over 4, comma 4. So y minus 4 equals m times x minus x1. All right, so then that gives you a negative 4x, and then a plus negative 4 times negative pi over 4 would just be a pi. All right, I got to kill this gnat because it keeps flying in my frickin' face. Y minus 4. And then you add the 4 over. And I got negative 4x plus pi plus 4. Do, 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 do. All right. Okay. And then we want the horizontal tangent. Hopefully that makes sense. Let me scroll down to make sure I didn't make. Okay, nobody else has touched anything. Okay, so that's the tangent to the curve at P. And then, okay, and then you have a slope at 0, Q. Okay, I get that part. How are you getting y equals 2? What's the x value there? Y equals... When did they do that one? Horizontal tangent to the curve. Horizontal tangent would mean your slope is 0. They give you any value. They don't give you a value for your Q. Well, what the heck? Let me come back to that one. Why is it escaping me right now? Horizontal tangent to the curve at Q. Okay, I don't have a problem with that. It doesn't surprise me that it's y equals. Then how are they getting, like, what is that actual point? How come you don't need it? Because then on the other one they did. All right, I'll come back to the part B part. All right. Let's see here. Okay, that was 32. Do a trig function derivative problem. You need to find me one. Yes, I will. I mean, this was one, but You can do more than that. Just find me one and I will do it. Page 107, number 26. Maybe I have it. Is it a typo in my, I don't know. Maybe it's a typo power 4. Oh, okay, I'm an idiot. All right, let me finish part B real quick. All right. Okay, well, let's try it. Okay. So that was part A. Part B. Part B wanted to know the equation of the horizontal tangent at Q. And they didn't give you a point, right? But it's a horizontal line, which means your slope equals 0. Well, that means when y prime equals 0. And your y prime, we figured out was, y prime was negative rad 2 cosecant x cotangent x, and then it was a minus cosecant squared. Okay, we want when is this guy equal to 0? And so you can solve this, and I can factor out a cosecant first and have negative rad 2 cotangent minus cosecant. This is so not friendly. And so it's when cosecant of x equals 0 or negative rad 2 times cotangent x minus cosecant x equals 0. So cosecant of x does not equal 0 because your r can't equal 0. It's like the reciprocal of sine, right? And so sine is never undefined, so cosecant would never be 0. This one is negative rad 2 cotangent of x. I could add the cosecant of x over to the other side. Is that what I want to do? I feel like I would do cotangent is cosine over sine, and then cosecant is 1 over sine. And if you multiply both sides by sine, you would have a negative rad 2 cosine of x equals 1. So cosine of x equals negative 1 over rad 2. All right, well then that means that it's you're either here or here. But if you do inverse cosine, it would be this guy. So 3 pi over 4. Right? And either that or 5 pi over 4. But if you look at the graph, 3 pi over 4 would be about, what, 9/4? So 2 point something. So it's got to be, your x value is 3 pi over 4. So 3 pi over 4 is your x value. Your y value, you got to plug it into the original. So it's a, this is ridiculous. I need to just stop because you're not going to have something like this crazy. Right? I don't think anyway. Cosecant of 3 pi over 4 would be a positive rad 2 over 2. No, positive rad 2. And then plus a cotangent is 1. I made a mistake. Cotangent of 3 pi over 4. Oh, that's a negative 1. That's why. It's a negative 1. Negative 1. And so you end up with a 1 plus 2 minus 1, which equals 2. And so your y value is a 2. And so when you plug it in, you get y minus 2 equals your slope is 0 times x minus 3 pi over 4. And so you end up with a y equals 2. Come over here because I ran out of room. Y equals 2 is your line there. Okay. That was crazy. Okay. All right, so trig function, yes, page 107, 26. The graph of the function shown here is made by the line joined end to end. Graph the function's derivative. Okay. Page 107, number 26. All right, so, I hate drawing on here. It's the worst. Okay, so it looks like we go from here to here, and then from here to here, and then like that, and then like that. Okay, and they actually gave you points. 6, 2. This one was 4, -2. This point here was 1, -2. That point here is 0, 2. And then this one is -4, 0. All right, so here is f of x. And they want you to graph the function's derivative. So derivative means slope. All right, so we're going to draw a line. From x equals -4, I have a certain slope from there to 0, and then I've got a different slope until 1, and then I have a different slope until 4, and then it changes slope at 6. Okay, so from -4 to when x is -4 to when x is 0, we have a slope of, so on this interval from -4, here I'm going to write it differently so that you're not confused between a point. Go, 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 go. Come on. All right, when x is 0. Okay, so from when x is between -4 and 0, your slope is straight up y minus y over x minus x. And so what is that? 2 over 4, so 1/2. And so that's a positive 1/2. All right, because you're going up 2, right 4. So here's 1/2, and I would do, you should just do open dots. Open to open. You got a slope of 1/2 from -4 to 0. And then from when x is 0 to when x is 1, your slope is -2 minus 2 over 1 minus 0. So that's a -4. Oh, I did not leave myself enough room, but let's go all the way down here from -4. Here's -4, so I'll have open dot there, open dot there. So from 0 to 1, I have -4 as my slope. From 1 to 4, from when x is 1 until x is 4, your slope is 0. And so I'll do open, open, connect. I should have done different colors on here. And then from 4 to 6, then your slope is 2 minus -2 over 6 minus 4. So is that 4 over 2? So 2. So my y values aren't really proportional, but hopefully you get the point of your slope now is 2 from 4 to 6. Let me see if I can do, here's green. All right, so here's the graph of the derivative is just the slopes. And you just plot the slope is your y value. The x values will be the same, those intervals there. Okay, so there's your graph of the derivative. for 26. And then at what values between -4 and 6 is the function not differentiable? Well, anytime there's a corner, right? When x equals 0, when x equals 1, and when x equals 4. So not differentiable at 0, 1, and 4 because there's corners. All right. Okay, that was 26. That was Bailey fixing my mistake. Yay. Can we go over number 1 from the quiz? Yes. All right, so we give you this definition of, by definition, f prime of a is the limit as h goes to 0 of f of a plus h minus f of a all over h. So we give you that, right? And then they want you to find the derivative of when f of x is 3 minus 8 an hour. Okay, 3 minus 4x squared at a equals 1. Okay, so I'm going to go ahead and just plug the 1 into a right now, right? So f prime of 1 will be the limit. You got to write the limit on every step or you do not get full credit of f of 1 plus h minus f of 1 all over h. And then that's the limit as h goes to 0 of f of 1 plus h would be 3 minus 4 times 1 plus h quantity squared, and then minus f of 1, which would be 3 minus 4, so a -1. I guess I'll write it. I can write it 3 minus 4 times 1 quantity squared. Okay, and then that's all over h. All right, so then this becomes the limit as h goes to 0, which you can't plug 0 into h yet because you'd be dividing by 0. But you end up with a 3 minus 4 times, expand out 1 plus h quantity squared, and it is a binomial. So it's the first one squared plus 2 times the first times the last plus the last one squared. And then we have a minus, that was a -1, so a +1 over there, and then all over h. All right, I am there. I need to go to a new screen. All right, so now I had, almost right, this is the limit as h goes to 0 of, it was a 3, I'm going to distribute that -4, so -4 minus 8h and minus 4h squared. So don't forget to distribute that -4 into all 3 terms of that expansion, and then all over h. And then this is the limit as h goes to 0 of 3 minus 4 is -1, and then you got the +1. So bye-bye, bye-bye, bye-bye. You get a -8h minus 4h squared. I'm going to factor out the h that they have in common so that it cancels with the h down below. And now you plug in the 0 into the h, and you don't write limit anymore. Once you actually plug it in, then you don't need to write the limit. It's -8 minus 4 times, I plugged it in now, which is just -8. So that is the slope of the curve. You know, that curve is a parabola opening down. So when x is 1, your slope is -8 there. That's what it's telling you. So, all right, that was number 1 from the quiz. Do number 23 from the multiple choice. Already did it, right? Isn't that the one I just did? Oh no, it's different, right? Is that the same? Which one did I just do? Oh, I did 11. Okay. Number 23 is identical. Why did we put both of them on there? Well, that's stupid. Well, good practice, I guess, huh? So multiple choice. Multiple choice 23. Alright, so they gave you y equals x cubed minus 5 all over 6x and add x equals 1. They want the equation for the tangent line. Off the curve. Okay, so you need a point, and that's just plugging in when x is 1, which is what, -4 over 6, which is a -2/3. And so your point will be a 1 comma -2/3, because it's an x comma y point. And then your slope is the derivative of y. And so I'll do quotient rule again. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Don't forget the bottom squared. Lots of you will forget that. And then I'm going to go ahead and just plug in a 1 right now to figure out what's the slope. Instead of simplifying all of this, which maybe I should, because then do you guys have to find it just regular? Probably. I don't feel like it though. What would it be? Whatever. Okay. So that would be a 6 times a 3 minus a 1 minus 4 would be, I'm sorry, 1 minus 5 would be a -4 times 6 all over 6 squared, which is what, 18 plus 24 all over 36. And that is 42 over 36. 6 goes into both, so 7, 6. All right, so we got a y minus -23, so plus 23, 2/3 equals 7, 6 times x minus 1, and then that should give you a y equals 7, 6, x minus 7, 6 minus 2/3 would be a minus 4, 6, so a minus 11, 6, I think. That was 23, we need 16. Okay. Ooh, that's a good one. Yay. All right. Here's some trig derivatives. Multiple choice number 15. They give you y equals x to the 4th. Cosine of x minus 5x times sine of x, and then minus 5 times cosine of x. All right, and they want you to find dy dx. Dy dx is just y prime, or the derivative. Oh, I was going to sneeze, but it didn't come. All right, so be very careful. You have product rule here twice. I have product rule of x to the 4th times cosine of x. And so product rule says you're going to take the derivative of the first times just the second guy, and then plus the first guy times the derivative of the second. Derivative of cosine is negative sine. Okay, so that was just the red part. Product rule of the first part. All right, then we have another product rule. Do I want to? Normally what I like to do is treat that minus sign. That's what I'll do. Be careful with that minus sign. If you're going to just if you're going to go minus and then the derivatives of these two guys, it's product rule again. Sine of x is one of them. What I do is I'll include the sign, the negative 5x. And then that way you can just add everything. If not, you got to put the minus sign and then put parentheses around the product rule when you get done there. So I'll just treat the minus sign with it, and then so that means it's a plus, and then it's the derivative of the first, which is negative 5, and then just times the second, and then plus the first guy times the derivative of the second. Derivative of sine is cosine. And then we have this last bit. Okay, so this part was just the green product rule. The last one you don't need product rule because it's just a constant times a function. So it's just negative 5 times that cosine. And so I'll just write negative 5 and times the derivative of cosine is negative sine. So that was, this guy was the gray part. All right, then we simplify. What do I got? I got 4x cubed cosine of x minus x to the 4th sine of x minus 5 sine of x minus 5x cosine of x plus a 5 sine of x. So I'm barely, like, I can cancel these two. But there are no other like terms or anything. Was it just ugly? Oh yeah, nice. Okay. And so what did they do? They threw the algebraic parts, they put it in that order. So they went negative x to the 4th sine of x, and no, I don't care if you rearrange them like this. And then they wrote the plus 4x cubed cosine of x, and then they wrote the minus 5x times cosine of x, and that was C. Okay, so it was 16, number 7 on page 146. You can do this two ways. They give you y equals 4 over cosine of x. So if you did quotient rule, it will work. It's just that 4 up top. You've got to, when you take the derivative of 4, it's 0. So you just got to be careful on that. So you can do quotient rule. But what I would do instead is this is equivalent to 4 times secant of x. 1 over cosine is secant, and so it's 4 times 1 over cosine. So it's that, and then that means it's the secant, tangent. Taking the derivative of secant is secant times tangent. So that means y prime is 4 times secant x times tangent of x. And did they want you to evaluate it? Nope. There you go. Oh, they said dy dx. So dy dx is the same thing as y prime. And so 4 times secant x times tangent x. Are we supposed to memorize the alternate definition? No, you don't need to memorize the definitions. We're going to, just like on the quiz, we'll give you, we give you both of those. Okay. Can you do number 9 on the quiz? Okay. Oh, this is when I wish you could see my thing. I need to figure out how to get like a snapshot. Can I insert like a picture? Wouldn't that be fabulous? Because that's what I really want to do. Wouldn't that be wonderful? But I can't. Okay. All right, so I'm going to do my best to draw these. It's horrible, though, drawing on this little board. Okay, so A looks like this. Meow, meow, meow. Come on, keep going. Meow, meow, meow. I don't know, something like that. Graph B looks something like do, 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 do. Okay, and then graph C looks something like do, 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 do. I don't know, something like that. I know those are horrible graphs, but that's okay. What you want to do is look at slopes and x-intercepts, right? Because here's the deal. Your derivative is the slope, right? And then when the slope is 0, then the derivative graph will be crossing the x-axis. So think of this. The derivative equals 0 means the slope equals 0, which means that the graph of the derivative is crosses the x-axis. Yeah, and the derivative or slope equals 0 horizontal, right? Okay, so that's what I'm going to do. I'm going to identify each of these graphs. I'm going to identify the x values where the slope is 0, slope is 0, slope is 0, slope is 0. It's always going to be at the top of a hill or at the bottom of a valley. So your slope is 0. At when x is, and I just guesstimated. I know these may not be right. You're just going to take guesses on approximate, right? So I said at negative 3.5, at negative 1, at 1, a little over 1, so like 1.2, and then like 3.8. And then the other thing I'm going to identify is where are the x-intercepts? Because we don't know which one of these is the derivatives of what, right? So the x-intercepts happen where the graph crosses the x-axis. So here, 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 and here are your x-intercepts. And so I said, and again, I'm approximating, I said negative 4.9, negative 1.9, 0, 2.1, and 5. All right, so that's for A. For graph B, you have slope equals 0 at, we want x values, right? So it's when it's here, here, and here. Those are when your slope is 0. Top of a hill, bottom of a valley. And so I said that it was at negative 1.9, at 0, and at 2.1. And then the x-intercepts were here, here, and there. And so I said that they were at negative 3, 0, and it looked to me like it was just a little more than 3, so 3.2. All right, and then C, do the same thing. Your slope is 0 when your x values are here, here, and here. And so I looked at the x values, and it was at, I said negative 2.1, 0, and 2.5. Right? That's what each of these x values, that's what I'm looking for, is the x values when I'm listing these. And then I have x-intercepts. I said that it was, okay, so it's this guy, this guy, this guy, and that guy are your x-intercepts, and I estimated them to be at negative 3.5, negative 1, 1.2, and 3.8. All right, so now the graph of the derivative, right? So it's your x-intercepts will be the derivative graph when the slope is 0 for the original graph. So you want to look for values that match. And so here's what I noticed. I noticed the negative 1.9, 0, and 2.1 matched when these guys' slopes were 0. Yeah. Which would mean that A is the derivative of B. That's my claim right now. And then any other matches? What else did I see? Oh, look, I've got x-intercepts at negative 3.5, negative 1, 1.2, and 3.8 when the slope of this guy is that, which means that C is the derivative of A. So the derivative will have x-intercepts when the original graph's slope is 0. So you just match those up. And so that's why f of x was B. Means f of x was B. The first derivative, the derivative of B was A, and the derivative of A was C. So it should have been BAC. All right, that's number 9. Number 7. Number 7 was a doozy, huh? Need to make the answer line longer. Is number 7. All right, we got y equals x cubed sine of x times sine of x. So this is very similar to the one I just did from, I think it was from the worksheet, huh? It's worth another go. Oh, this one's even easier because you've only got one product rule instead of 2 like the other one. Okay, this is, what time are we at? 6:02. Okay, so this will be the last one I do then because we are at time. All right, so we got that. Okay, so now derivative y prime will be, you got to do product rule on this guy, x cubed, and then sine product rule. Yeah, so I'll treat x cubed like the first guy. So you got the derivative of the first, just times the second, plus the first guy times the derivative of the second. So derivative of sine is cosine. So that part was just, this part here was just the red part. All right, then secant. All right, I'm going to write it up here. Psst. Secant, secant, tangent. Here's my little cheat sheet. And then I'm going to need cotangent anyway, so I'll write it again. Cosecant, cosecant, cotangent with a negative in the middle. Okay, so that now I've got minus secant means that I will have a minus secant x times tangent of x, and then plus 3 times derivative of cotangent would be a negative cosecant squared. All right, so that's, is there any cleaning up to do? Not really, huh? I wrote the x cubed first, not that it matters. Was there any, there were no like terms, right? So you just write it as 3x squared times sine of x plus x cubed times cosine of x minus secant x tangent x and a minus 3 cosecant squared. And there you go. Done. All right. Calling it a night. Good luck. Hopefully that was helpful. I think I got all of your questions, I believe. I believe. All right, good luck. I'm going to post the link to the recording in the chat window and just give me a couple minutes and I will put it in there.